We're going to do one more walkthrough of a one-way ANOVA from start to finish. And this ANOVA is going to look at the relationship between feedback on parking ability. So in this problem, feedback is our independent variable, parking ability is our dependent variable, and we're going to divide people into one of three conditions. Some people are going to be given good feedback, some are going to be given bad feedback, and some are going to be given no feedback. And we're going to measure their parking ability by the number of times they hit reverse in a parallel parking simulation. All right, so anytime you see data, the first thing you're going to do is summarize it. So we're going to start with our sums, and remember in the ANOVA we're doing capital letters to represent sums. So the sum of column A1 is capital A1, and the sum here is 2. Our n A1 is 4, there's 4 observations here, and our y bar, or our mean for A1, is 0.5. Moving on to A2, we're going to use the same kind of notation. So capital A2 is the sum, and that's 22. N A2 is 4, and y bar A2 is 5.5. And then moving on to our last column, capital A3 is 8, N A3 is 4, and y bar A3 is 2. All right, little a, remember little a is the number of levels. So our little a in this problem is 3. Little n by itself is the number of subjects per group, or the number of observations per level. So in this case it's 4. Capital T, this is our grand sum. It's the sum of all the scores. If you trust your math for your column scores, we can just add 2 plus 22 plus 8. And T equals, what does T equal here? I don't know why I don't have my T. T equals 32. And then y bar T, I think I did that right, is T 32? Yes. And then y bar T is T divided by little a times little n. So that's 32 divided by 3 times 4, and I don't know why I don't have this on my notes here, but I'll do this real quick. 32 divided by 12 is 2.67. So our y bar T is 2.67. All right, so once we've summarized that, again, the importance of labeling things properly cannot be understated enough, because we're going to need to refer back to these calculations as we move through the problem. So once we do all this stuff, the next thing that we are going to do, I think I'll change the ink color for this, is we are going to calculate our basic ratios. And in the one-way ANOVA, there are 3 basic ratios. So our first basic ratio is the basic ratio for y, and the formula for that is the sum of the y squareds. So we're going to take each one of these 12 y's, square them, and add them up. So we have 0 squared plus 1 squared. Why is this not working? Plus 1 squared plus 1 squared plus 0 squared. Moving on to the next column. Plus 4 squared plus 6 squared plus 5 squared plus 7 squared. And then moving on to the third column. Plus 3 squared, 2 squared, 1 squared, and 2 squared. So I know that's super messy, but all we're doing here is we're taking each one of these scores, squaring them, and adding them up. And as always, I encourage you to actually do this on your calculator yourself rather than just relying on my numbers. So I would pause the video as you're moving through this. But when we do all these things and we add all these things up, our sum should be 146. So our basic ratio for y is 146. Our next basic ratio is the basic ratio for a. And the formula for this is the sum of the capital A squareds divided by n. So if you look back to your data, your capital A's, these are your 3 column sums. So we have 2 squared plus 22 squared plus 8 squared, and then we're going to divide by n, which is 4. So when you do all the math on that, you should get 138. And then finally, we have the basic ratio for t, which is t squared divided by little a times little n. So our t is right here, it's 32. We're going to square that and divide by little a times little n. So t squared divided by 3 times 4, or 32 squared divided by 3 times 4, and this is 85.33. Okay, so before you move on, you definitely want to stop now and check your work to see if these numbers make sense. Y should be the biggest of the 3, which it is, and t should be the smallest, which it is. All right, so in the next video, we are going to start with the sums of squares.